So what we're going to do today is we're going to revisit a case study that we talked about a couple months ago when we were focusing on Spring Web MVC, but now we're going to revisit it in the context of Spring WebFlux. And so this is the PrimeCheck app case study, and basically what we're going to do is show how we can use the Project Reactor framework mechanisms, in particular the flat map concurrency idiom and also the parallel flux mechanism to, in conjunction with Spring WebFlux, to check the primality of large, odd integers. And we're going to do this asynchronously instead of synchronously. So let's start with a quick overview of the case study. So we'll have a client that will send requests asynchronously using the HTTP interface mechanisms that we've been talking about, that you've been getting a chance to play around with in your assignments. And it'll send these things from the client, and it'll also do something really cool. We'll talk about this more in a second. It's actually going to pass the contents over as a flux. So the parameter that's passed is a flux, which is kind of interesting, and you'll see how you have to tweak stuff a little bit to make that work properly. So that's the big picture view. The client can send these requests either one at a time in parallel, using either a parallel flux or the flat map concurrency idiom, or it can send it in a bulk. It can send all the requests as a flux in one fell swoop. And the server can receive the stuff individually. Obviously, if the client sends it individually, the server handles it individually, or in bulk, and it'll process the requests in parallel using one of two different Project Reactor frameworks, either the flat map concurrency idiom or parallel flux. The controller, as is always the case, takes the incoming requests that are the get and post requests and then converts them into the corresponding Java types, including fluxes, which is cool, and then it forwards them to the service for processing. And the service is implemented in a somewhat clever way because it uses this indexing array to then forward to the appropriate strategy. So the strategy comes in as a parameter, and then there's like a demultiplexing operation that's used to get to the right strategy implementation. And then the strategy does the processing in whatever concurrency model, parallelism model has been designated based on the client request. So that's kind of the overview of things. Let's talk a little bit about how it's structured. As usual, it's got a couple of packages. We've got a main package, which is where all the interesting server-side code goes. And then we have the tests package, which is the client side. So the server's got typical server folder that has the usual microservice, controller, and the service capabilities. And then it's got a bunch of strategies. We just have two at this point. We have a common folder where we put project-specific helper classes. We have a utils directory where we have these generally reusable helper classes that you could use in lots of other projects. And then we have a resources file that keeps track of things like the name of the server and the port number that it listens on. We are not using a Eureka name service here. It's a very simple example. The client side is the test program, and this is very cool. It uses the Spring Boot test framework, which can auto-launch the server to do the testing, and it measures the time needed to send these requests. And we'll kind of do a bake-off to see which one is faster. The client sends the get and post requests to the server using these different frameworks, and there's some common stuff, and then there's some general purpose utils. So what are the pros and cons of doing things in this particular way? This is really something that could have come a little earlier in our discussion before we talked about things like the gateway and the naming service and so on. But basically, we simplify stuff so everything runs in one process. Why that is useful is because we can have the test program auto-launch the one and only microservice, which is much simpler than trying to run things manually by starting them up through a multi-run configuration script and so on. Another nice approach, another benefit of this way of doing things is that asynchrony may enable greater scalability modulo certain assumptions. We've talked about those kind of assumptions before, why asynchrony could be better and when asynchrony might not be better, and so on and so forth. The downside, which is the flip side of the pro, is that everything runs in a single process. While that's easy for configuration point of view, it may not be the best thing in terms of larger scalability in like a cloud environment. And of course, if something goes wrong with this process, we're just completely stalled. So a real system would probably use other approaches, but this is just for testing. And as you'll no doubt notice, as you write assignment 3 and maybe even doing a little bit of assignment 2C, when you start doing asynchronous programming, things get a little bit trickier to develop and debug because you have to get your head around the concept of asynchronous programming, which is really fun once you get the hang of it, but can be a little bit mysterious at first. So that's the end of the overview of this reactive PrimeCheck app case study.